Good morning. This is the second lecture of method of section. In the previous lecture, we have discussed a few basic things about method of section. What are the different steps involved in method of section? And in this particular video today, we will solve one particular problems so that you can understand the method of section quite comfortably, and all your doubts of how to solve some problems using method of section will be cleared, I think. So we will start now. Suppose this is one particular truss and we have to solve this particular truss using method of section. And so far you have already learned how to solve for the unknown reactive forces, how to figure out the unknown reactive forces. So we are not wasting much time in the finding out the unknown reactive forces. So in this particular truss, at point A there was one hinge support, one hinge support was there at point A, and one roller support was there at point H. So corresponding to that, at roller support there will be one vertical reaction, and we already have figured it out, and that is 135 Newton. So this is one reactive forces, and at point A there will be two reactive forces. So we have already solved for this reactive forces. So the blue colors represent the reactive forces which we already have solved, and you have already learned in your previous engineering mechanics courses how to find out the unknown reactive forces. So we are not going to that in much extent. So directly we are going to our method of section, how to solve for the unknown member forces using method of section. Now this is one particular truss and we have to solve using method of section. The basic first step was to draw the free body diagram, and the second step was to find out the unknown reactive forces. So these two part we already have done. Now the third part is that we have to cut a section, and it is very important that we have to cut a section in such a way that there is not more than two or more than three members, because we don't want more than three unknown member forces. So let me cut a section like this. So if we cut a section, then what happened? 1 2 3, this is cutting three members, so there will be only three unknown member forces, so our purpose will be solved. Now if we just if we keep it out from the whole truss, then what will happen actually? Let me erase first. Now we are just making it out from the whole structure. Now this is the left side. This was we have just kept two section aside, and we are just considering the left portion. We are dealing with left portion only at the first part. So if we keep only the left part, then what will happen actually? The point D was there at this particular point C was there, and we have cutted the section. And it is very important, when we are cutting a section, the internal force must be shown, the member forces must be introduced. Whenever we are cutting any section within a member, the member force must be introduced in order to fulfill the equilibrium, the conditions of equilibrium. So if we do that, then what will happen actually? You can see so this is we have just only taken that part, and you can see as in BC there was unknown member force. If BC is there, and at FAC there is unknown member force FAC, and at FBD there is also one unknown member force. But what will be the direction of those unknown member forces? You can consider any direction. You can assume any direction primarily, and depending on the values, whether the value are coming to be positive or negative, depending on that you can decide whether the force is compressive, the member force is compressive or tensile in nature. This is one aspect. And another concept you can use uh, to actually find out, actually you can understand what is the actual direction even before starting the computation. So how if we can understand that even before the computation, then we can give the direction accordingly. Suppose in case of FBC, what we can see that there is one, this is one vertical member force, vertical member force, and we can see from the whole structure that there is only one vertical forces other than FBC, and that is 15 kilonewton upward forces. So in order to maintain the equilibrium, the FBC must be downward and should be equal to that 15 kilonewton. So from that we can assume, we can say that FBC will be tensile in nature in order to fulfill the equilibrium. So that's why in our case we have all directly assumed it to be tensile forces. Now if we consider point B, if we consider point B and if we take the moment with respect to point B, then what will happen actually? You can see, take the moment about B, this force have no contribution. If AC is acting, if we take the moment about B, then if AC is acting in the counterclockwise direction, if AC, just forget if AC, so 15 kilonewton and 20 kilonewton, these two forces are acting clockwise with respect to B. If we take moment from B, both 15 kilonewton and 120 kilonewton force that is acting at A, those two are acting in the clockwise rotation, and this force have no contribution, this and this force also have no contribution. So in order to maintain equilibrium, in order to give some restriction to this clockwise movement, there must be anti-clockwise movement that will be acting. So there will be some anti-clockwise forces that will be acting within the structure in order to maintain the equilibrium, that is sum of moment at point B. And so we have the unknown reactive force at point at this member, that is FAC. So in order to maintain equilibrium, FAC must be in anti-clockwise direction in if we take moment from point B. So that's why we have given FAC in the anti-clockwise, shown FAC in the anti-clockwise fashion. So it is coming out to be a tensile forces so far as the sign convention is concerned. Now from this aspect we can by using the basic concept, we can easily find out whether the force is compressive or tensile in nature. Now if we again if we consider moment about C, then what will happen? You can see the 15 kilonewton force, considering moment about C, 15 kilonewton force at A and 120 kilonewton force at B, both are acting in the clockwise fashion. So in order to maintain equilibrium, FBD must act counterclockwise. So that's why if BD and if we apply counterclockwise force in that particular this member, then it will be this will be compressive sign convention. So that's why we have taken the direction of the member forces like this and these are tensile and FBD is compressive in nature. Now we have to go for the next step, that is solving the equations using equations of equilibrium. So if we do that, if we solve this particular problem using equations of equilibrium, the first of all what we are doing, we are actually applying equation sum of Fy equals to 0. So if we apply sum of Fy equals to 0, we can easily see that there is 15 kilonewton force and FBC. These are the only vertical forces that are acting. So FBC will be equals to 15 kilonewton. You can easily say from the visual observation as well. So even though we are keeping it in tabulation sheet. So from that sum of applying sum of fy equals to 0, we are getting plus 15 minus fbc equals to 0. So that comes out to be fbc equals to 15 kilonewton 15 newton tension. Now take moment about b equals to 0. Actually what we need, we need to solve for the unknown forces. So in order to solve for unknown forces, now if we take sum of forces, sum of all horizontal forces equals to 0, then we will have this one and this one as unknown. So we cannot directly, using only that equation, we cannot solve for that. So that's why we have to first take the moment about any particular point, that may be point A or that may be point B, so that in order to we can find at least from FBD or FAC. If one is known, then we can use sum of fx equals to 0 in order to find another one. So now we are taking moment about B, and if we take moment about B, this force will have no contribution, this force will have no contribution. The contribution only FAC, in the unknown member force will be only FAC, that will be contributing in this moment equation, and our known forces is there 15 Newton and 120 Newton. So if we apply that, if we apply the moment, then what will happen? Actually we will get minus 120 into 3 minus 15 into 4 plus FAC into 3 equals to 0. You can see, because these two 120 and 15 is negative, because these two is acting actually clockwise in nature, whereas FAC is acting anti-clockwise. So that's why FAC is positive and this two is negative. So this comes out to be 0. Summation will be 0. So if we solve for this, we will get FAC equals to 140 Newton, that is tensile in nature. So now using method of section, we have already determined two unknown member forces, that is FBC, that is 15 Newton, and FAC, that is 140 Newton. So using the same concept, just taking the same concept, now take moment about C, or take sum of all the horizontal forces equals to 0, whatever you can choose. Here we have chosen sum of moment at C equals to 0. So using this equation, you can see, if we take the moment about C, what will happen? Actually, if we take the moment about C, there will be no contribution of this and this force, so there will be only contribution of FBD. So from that we can easily get FBD, and FBD is acting anti-clockwise in nature. So FBD will be positive. 120 Newton force is acting clockwise, so it will be negative. 15 kilonewton, 120, the force 120 Newton will have no contribution, because it is passing through this particular point C. So 15 kilonewton force is again acting in the clockwise fashion, so it will be negative. So 15 kilonewton force into 4, this is negative, minus 120 into 3, this length is 3 meter, you can see from here. So 15 into 4 minus 15 into 4 minus 120 into 3 plus FBD into 3 will be equals to 0. This will be our moment equation at C. So if we solve for this, we will get FBD equals to 140 Newton, that is again compressive. So using this way, using this similar concept, we can solve for all the members. So we have taken one particular section, and we have taken just from one section we have got three unknown member forces. So if we want to figure out all other forces, we have to again cut different sections. So when drawing your section, include the points that the cut member would have connected to, if not cut in this is very important, that when you are drawing your section, you must include that points that would have connected to. If not, then you will not get the value of that particular point. And this one is very important. Each member that is cut represent an unknown force. So when you are cutting a section, you must represent that unknown force using giving some member forces. So that is very important. If you forgot to mention the member forces, your configuration will be wrong. Now, if possible, take moments about points that two of the three unknown forces have lines of forces. What actually this means, actually, if we go to the previous slide, you can see that we have considered, we have taken moment about B, we have taken moment about C. In order to find for the we have taken moment about C in order to find FBD. We have taken moment about B in order to find moment the member force FAC, but we have not chosen point A, because if you see that at point C two forces is going through that particular point, so there will be only one unknown forces. At the same time at point B also two forces member for two unknown member forces, unknown, I am talking about unknown member forces, two unknown member forces is going through that particular point B, so there will be only one unknown member forces if we take moment about B. So we can easily solve for one unknown, but if we take moment about A, you can see we have only one unknown member force if AC is going through point A. So we have two unknown member forces, that is FBC and FBD. So using so taking moment about A only, we cannot solve for FBC or FBD at the first step. So we have to uh, go to the we have to solve using some next steps also. So that's why, so if we, while choosing the point about which we are taking moment, it is very important to understand which point to take, because if you take that particular point where two unknown member forces is passing, through which two unknown member forces is passing, then there will be only one unknown member force left with, so you can easily solve for that unknown member forces using that moment equation. So that is very important. Now after that we are cutting a section in this part. Previously we have cutted a section like this, now we are cutting a section like this. So cutting through BD, CD and CE. If you look at the whole figure, you can just figure it out how it was actually. It was continuous in this particular side, so we have we have taken a section at this particular point and we have just taken it out. So their unknown member force will be there, so FBD is there, unknown member force FCD is there, unknown member force FCE is there. And one thing you must remember, that you have to show the point D and E, because the unknown member force where these member forces are actually going, you have to show that particular point actually. Now, you need not to mention other point in the right hand side, but the member force at where we are cutting actually, while we are mentioning the member force, it is very important to identify from which direction the member force is coming. So so you have to mention the point D and E only in this particular case. So these are the unknown member force. Again we will follow the similar steps. We will take moment about we will take take the sum of all vertical forces equals to 0, we will take sum of all horizontal forces equals to 0, or we will take a moment about D or E or C as per our convenience. So we have first primarily taken sum of all the vertical forces equals to 0, and this comes out to be FCD equals to 25 Newton. So if you can put it, you can easily find out that because this 3/5 is actually in this particular figure, you can see that the dimension of different members have been given. So as the dimension of these members have been given, actually sum of Fy equals to 0 if we apply, then this is the known member force that is acting in the positive y direction, so 15 kilonewton will be there. And what are the other vertical forces? the component of FCD in the vertical direction, that is the unknown member forces. So FCD, and if this angle is theta, if this angle is theta, so FCD's cos theta will be equals to 15 kilonewton. So 15 kilonewton minus FCD cos theta will be equals to 0. And if this is theta, if this is theta, this is 3 and this is 4. So what is cos theta? And if this is 3, this is 4, this length will be root of 4 square plus 3 square, so it will be 5. So cos theta will be equals to 3 divided by 5. So that we have done in the this particular 3 by 5 FCD. So we have taken the cos component actually. So by solving this, as we have only one unknown, you can easily get FCD equals to 25 Newton, that is compressive in nature as per our sign convention. And if taking the compressive sign convention, if the value comes out to be negative, you need not to worry. It actually indicates that your the member force is tensile in nature. So you need your problem is not wrong actually. Actually, you have to, while mentioning compressive or tensile force, you have to mention that. Now M, if we take moment about moment about D, then we can easily solve for FCE. So you can see that if we take moment about D, take moment about D, why we have chosen? Because two forces is passing through point D, so there will be only one unknown forces, that is FCE. So taking moment about D, we can easily solve for FCE, that we have done in this particular case, and FCE comes out to be 160 Newton. So just using same concept, no difference in the concept, just repeatedly we are using the same concept, and ultimately we are finding out the unknown reactive forces. And now if we take the right hand side, actually, we can solve those equations using taking the right hand side of the section as well. So that depends on what you like, what you actually want. So there is no problem at all if anyone solve the problem taking the left hand side of the section, or anyone taking the right hand side of the section, no problem. The problem will be as it is, the solution will be same. Now for this problem, if we take the right hand side, then also there will be three unknown member forces. So and we can easily solve for these three unknown member forces using equilibrium equation. Sum of vertical forces equals to 0, sum of horizontal forces equals to 0, and sum of moment equals to 0. So if we do that, sum of Fy equals to 0, we can easily get F dg equals to 25 Newton, which we have already calculated from taking taking the left hand side. At the same time, we can calculate FDF using the taking moment about g, and we can compute MD taking if EG taking moment about the D, and we have we actually we have seen that the same value was there, when while analyzing the truss using the we have analyzed the truss using left hand side, the same value was there. So the value will come out to be same even if we take left hand side or right hand side, so no problem will be there. Now after that, we cut a section in this fashion. If we cut a section in this fashion, then the problem will be same. There will be some unknown member forces, so FDF will be there, and FG will be there, and FGH will be there. So now we can solve for this, taking sum of Fy equals to 0, sum of Fx equals to 0, or sum of moment equals to 0. And if we do that, we will get, taking sum of Fy equals to 0, we will get Fg equals to 15 Newton, that is compressive in nature. And taking moment about F equals to 0, we will get that Fgh equals to 180 Newton tensile in nature. And why we are writing tension and this one as compression? Because actually if we look at the figure, this is Fg, and if we look at the figure Fg, this is Fg, we have assumed a compressive sign convention. Our arrow represent that this force is compressive in nature, and representing compressive forces, if our value comes out to be negative, then it is actually compressive. And if we are representing it as a compressive forces and if value comes out to be negative, then it's not a compressive, it is actually a tensile forces. The same thing happened in case of FGH. This is, we have assumed to be a tensile forces. So if this value comes out to be positive, then it is actually a positive force, tensile forces. So that's why we have mentioned tension here. Now the rest of the member A, B, D, E and FH, we can easily solve for that. If we go to the previous, our original truss, we can see that. So this was our original truss. First we have taken a section through this. Just let me draw the section what we have taken. Sorry. First we have taken a section like this. Next we have taken another section like this. Next we have taken another section like this. So you can see from there that while we have taken this section, let's change the color. Now after analyzing this section, the value of this member is known. The value of this, the member forces of this is known, because we have analyzed this. Now from this also the unknown member force in this is also known to us. We have solved for it. We have solved for this member force as well. While taking this section, this was previously known, so no problem at all. So taking this section, we have solved for this member forces, and also we have solved for this member forces. Now taking this particular section, uh, we actually have solved for this member force, this member force and this member force. Again we have taken another, sorry, I have forgot to mention here, we have taken another section at this particular point, and using that we have considered the right hand side, and considering that we have found out what is the unknown member force here and member force here. So you can see that using these sections we have found out all the reaction, all the member forces. Only few is left. This one, AB is left, still left, DE is still left, unknown member force DE is still left, and unknown member force FH is still left. So we can also solve these three unknown reactive forces, just taking another section here. If we cut a section here, you can see this is very similar to method of joints. So if we cut a section using this, taking the right hand side, we can easily found just unknown member force F GH, and this is very similar to method of joints. You already have learned this. And if we cut a section here, we can easily solve for a member force AB, and this is also very similar to method of joint. So this is very easy for you to solve. So take out the free body diagram of the left side of this cut, and just analyze, apply sum of fx0 and sum of fy0, and this is also left, DE, the member force DE is also left, and there is no hard and fast rules that the section have to be taken in the right direction, I mean in one direction. That there is no hard and fast rules like that. You can take section like this as well. Like in order to if we want to analyze this particular member, that is we have to analyze the member force DE, we can take section like this. There also the it is cutting 3 members, so no problem at all. And if we analyze the lower part of this section, then it is also very similar to method of joints. So just applying sum of fx0 and sum of fy0, we can easily solve for this. So this is the basic process that are involved, and we have already solved this equation. So this part I am giving to you to solve this. You have to solve this. You will do it. I think you can do it by yourself. So I think you have understood all the steps involved in this particular method of section, and thank you.